In this video, I'll briefly highlight some of the major features of the code. I'll send a link to the complete source on Bitbucket as well, so I'll skim over this pretty quickly. I've organized things into three separate sections. Firstly, we've got our Python module that connects to the Shotgun database, the C++ static library that holds the Shotgun entity class structure that we're using to mirror the underlying data, as well as the Shotgun connection object, which is what the Unreal plugin holds. And then finally, the Unreal plugin itself. So here we are on Startup module, and I've got my onWorld created delegate. As in the sequence diagram, we're loading all task templates for project and loading all users for project. That's done through our master connection object. Then we interrogate the scene, and first of all, we get all Shotgun tracked actors. And then for each that is, we get all tasks for asset. So that loads the repository like we talked about before. Here's our context menu extension delegate. I'm mapping the swap and invert delegates here. Another delegate, fill plugin menu options. Here's our master logic, depending on how many actors we've got clicked. So if we have 2, we get the swapped actors location. If 1, we get the invert, and then the shotgun. Depends whether we have an underlying shotgun data component. If we do, we end up calling build task assign menus. If we don't, build task template creation menus. The task maps are the main data structure we're weaving through the submenus. And we can see here that it's a nested map of pipeline step, task name, username. And once we've got the tasks, then we unpack everything, or load it rather. Find or add, pipeline step, task name, username, and payload. This is level 0 of the task assign menus. We're getting our cascading maps, passing them onto the fill pipeline step submenu. That's where we get the menu builder, of course, and we're passing the cascading maps as an argument or binding it. Unpacking the keys as pipeline step, and for each, the next submenu delegate. So it's step 2 here now. Now we're at task name, the next delegate. And this is where we create the actions. We don't want to create a new action every time the user visits the same menu, so we have an assigned task action lookup. If it already exists, we simply map it. If it doesn't, we create a new one. That's the task assign. The build task template creation menus works in the same way. There's our delegate, and here's our submenu unpack. Task template name being, of course, the main thing we're interested in. And finally, our action mappings, Shotgun user task assign. There's our connection object. All we need is the IDs and task template creation. In this case, new Shotgun data component is what we're going to wrap up the returned new tracked asset ID, and we're going to attach it to the selected actor. That means we can track things in future and start assigning things. And I left these in for completeness. These were originally developed first, as I got my head around how the delegates worked. Placeholders for future work. Over in the static library now, here's our base class of Shotgun entity. Here's our Shotgun task. Assignees asset pipeline step. Various other subtypes. The repository with the master map of Shotgun entities. And then I've stratified them as well into their various subtypes. Some of these we're not using there for future development, mostly for speed of retrieval. This is our templated find or add, and we're both storing by type and by base class. Important to keep those in sync. We have our shotgun connection class, and here's where the heavy lifting happens between Python and C++. This is straight out of the python.h documentation. Everything's a Python object, and there's some attempt made to reference count it to keep track of how many things are pointing there. It's very brittle, and especially when you start using nested loops, things get out of hand quite quickly. In future, I think I would refactor this with something like Boost Python. There's a lot of code that looks like this, but it's not similar enough to refactor. So you'll see this looks very similar. Lots of Python objects, lots of extractions. It does work, but it's very brittle and it'll fail easily. So we've got to refactor this completely, null checks, error handling, all that type of thing for future development. And then lastly, our Python module. Here's our master shotgun connection. Our queries are done in exactly the same way. We use a find, and what we care about is the entity type. In this case, it's human user, it's a shotgun term. The filters, SQL type, syntax there, and then the fields we care about. Here I'm doing a bit of post-processing as well, and then we return our package users ready for C++. Assign task to user uses the shotgun connection.update, so we're checking the existing assignees. If we're not already assigned, we simply update that field. And then lastly, here, create asset with task template we call in create, where we have our data. We just call that once. The result coming back in this case is the shotgun ID. So that's all. Super quick fly through of the code, and I'll put up a link to the main repositories.